5 tips to avoid expensive plastic injection molding mistakes. Do you know that poor supply performance when making plastic injection molded parts can be wickedly expensive for product developers because of inconsistent quality, unreliable performance, and long production times? If you want to avoid this, stay tuned for 5 helpful tips about what to look out for in your supply chain. Hello everyone, this is Laura from Alpine Mold. When done right, plastic injection molding is the best way to make large quantities of finished plastic parts at relatively lower cost. But achieving great performance depends on carefully monitoring and controlling those 5 parameters. Does your suppliers check all of those boxes? Reducing cycle time to a minimum is the single best way to lower production cost while still maintaining product quality. Consider a single circle that takes 1 second longer than it should. For a production run of 1 mini circles, that adds up to almost 238 hours of extra cost, and that means lost profits for the suppliers, who may in turn pass those costs on you or cut down on quantity to make up for the shortfall. Some examples of waste time might include manually unloading finished parts from the mold, handle loading inserts, spraying release agents to the mold, inspecting parts in line, or waiting to load fresh raw material. Now I could like to make a point here through. For components that do potato and low volume production, you will see some of what I have just described here. But once you start to get into anything that looks like higher volume production, those must be eliminated. Conversely, solutions include automatic loading and unloading, automatic inspection, improved tool design, and the use of specialist mold coatings to reduce friction and improve tool life. Since every production job is unique, there is no one solution that works for everyone. So you really should work closely with your supplier to consider your options before you start productions, because there are things that you can do to the design of the parts that helps with those manufacturing solutions. For example, using Robert's end of the army, tuning friendly non-surge, and increasing draft angle to avoid sticking parts. You really want to keep excess water vapor out of your plastic resin pellets, because when it gets hot, it bumps, boils, toys, and troubles. There are 4 ways to control moisture for molding. Firstly, the plastic resin pellets should be dried and kept dried according to the manufacturer's specifications. This is done with hot air dryers or decent dryers, but hot air dryers only work when the ambient relative humidity is below 15%. So for most of the time, here in South China, they are useless. Pro tip: if your supplier's factory is situated in a high humidity area, order them to throw away their hot air pellet dryers and get destined dryers, or fire the assets. Secondly, use a hygrometer to test your material after drying. We have actually seen suppliers here in China that have dried their material for hours in a hot air dryer and actually quantify the moisture content compared to the raw material in the sealed plastic bag from whence it came. How ironic is that? Thirdly, try specifically materials that are hydrophobic, meaning they don't absorb moisture in the first place. And fourthly, find a supplier that keeps its factory at controlled temperature and humidity all year round, as best you can, and this is no mean feat in the tropics. If you don't do this, you will be endless having to change your molding parameters. There are 4 pressure settings related to the molding: injection, packing, back pressure, and clamping, and they interact in complex ways. Therefore, one of the primary jobs for the pressure engineers is to balance them out to achieve a stable result in the shortest cycle time. At the beginning of a new project, there is a relatively long setup and testing phase. This is when the technicians test various knobs and push all kinds of the funny-looking buttons. However, once the ideal settings are confirmed, they must be recorded and strictly adhered to for all subsequent production runs. The only reason why those settings might change over time is due to normal wear of the motor tool. The best way to ensure stable pressure settings is to use quality equipment that's regularly served and maintained. Only machines in good working order without leaking or faulty gadgets can be relied on to maintain their integrity circle after circle, along with a regular maintenance schedule. Air cleaning and ordering workspace helps to identify machine leaks that can lead to pressure loss, and using automated control software prevents any deviation from the optimum pressure settings once they are established. Pro tip: ask your supplier to prove that they have and store all molding parameters in digital and possibly also paper formats, and that they are kept safely and backed up. There are many suppliers that they don't, and every time they pull out your mold, they are effectively retrialing your mold 8 times. To achieve stable performance for high volumes, the supplier must carefully control temperature of the resin at every stage. First, the resin is heated in the barrel to its ideal melting flow temperature, and this is maintained for the shortest practical time needed to complete one injection cycle. Why do you want to limit this time? Because otherwise, the molecular bonds of the plastic will permanently degrade, making it useless. In fact, some suppliers will change the size of the barrels on their machines for different jobs. They do this minimize the volume of resin that's molten at any one time. And this is why sometimes you might see a relatively small barrel on a large machine. How is temperature regulated in the mold? The secret lies with the complex cooling circuits that surround the core and the cavity. Although the term cooling is slightly misleading, it's more accurate to say that coolant distributes heat evenly around the mold core and cavity, so it acts more like a temperature regulating mechanism. That's why not only the temperature of the coolant, but also its volume and the rate of circulation must be controlled to achieve constant molding parameters. Reputable manufacturers must safeguard the integrity of their material supply chain. This is especially challenging if you are dealing with potential hundreds of types of resin compounds from many global suppliers. For example, different formulations of nylon might mold the same way and the finished parts look identically, but that can discuss some very serious difference in mechanical and chemical property. The only way to ensure conformance to specifications while meeting the customer's regulatory requirements is through positive material identification of every batch of raw material. We have several videos on this. Please forgive us for laboring these points. but it is a major growth problem. Now you might ask, what does that have to do with optimized cycle times? Well, imagine if a resin formulation changes, even slightly, from one batch to another. This can lead to substandard parts as well as causing the molding conditions to fluctuate. It will take time to find the roots because of the problem, and it might also mean the suppliers ask to retrial and optimize the process again, more time and money lost. To recap, look for suppliers that control cycle times, moisture, temperature, pressure, and material input if they are going to offer you the best results for plastic injection molding. Using this knowledge, you allow a better position to evaluate the performance of your current supplier partners. And that's all the time we have for today. If this was helpful to you, please like, subscribe, and share.